Hello, my name is BT, and I'm pleased to present the 2026 CSTA Pre-K-12 Computer Science Standards. These define the learning to prepare every student for a world powered by computing. These standards articulate coherent learning progressions from pre-kindergarten all the way through grade 12. They're organized as grade level specific standards at the elementary level, and then a band of standards at the middle and high school level. They represent a comprehensive revision to the 2017 CSTA standards, which are the de facto national standards of the United States. They have been used by 46 US states to adopt their own K-12 standards, which are remarkably similar to the 2017 CSTA standards. These new standards, the 2026 standards, were built to reflect how computing and its role in society has changed over the last decade. They were developed for and by CS teachers using a set of community-defined priorities. They are grounded in research. In fact, much of the 3+ year revision process was focused on using research to inform the development of the new standards. And they were released just in July 2026. The content is not all different, though there are significant differences. There are a set of enduring priorities shown in blue at the top. These are algorithms, programming, data analysis, and computing systems. These represent what is similarly important as the past or the current standards in 2017. At the bottom in purple are the emerging priorities. These are new or elevated importance, and these include ethics and impacts, AI and emerging tech, human-centered design, inclusive collaboration, history of computing, and career exploration. Chief among these is ethics and impacts, and we've woven that across the standards, what we call a socio-technical approach. Next, I'm going to show the structure of the standards and how these priorities are kind of put into the standards. And there are three main components. There's the concepts or the knowledge the students develop. The practices are the skills and the behaviors the students develop. And the dispositions are the habits of mind the students develop. I'll start with our vision again. This is every student prepared for a world powered by computing. This vision allows students to demonstrate seven key dispositions. Those are creativity, critical thinking, curiosity, persistence, reflectiveness, resourcefulness, and sense of belonging. We realize this vision through the intentional weaving together of concepts and practices. The five horizontal colored bands represent the concepts that organize the content. Those are algorithms and design, programming, data and analysis, systems and security, and computing and society. There are four interwoven vertical black bands, and these represent categories of practices. And again, the practices are the skills or behaviors that students develop. Those practices are ethics and social responsibility, human-centered design, computational thinking, and inclusive collaboration. And as you look at this, you may be wondering, well, if AI is a priority, like why don't I see it in the structure? Well, we believe that AI is very much part of CS and does not replace CS. In fact, it makes foundational CS even more important. And we've chosen to weave AI content across the CS concepts. I'll give you a little preview of what this looks like. For example, when students learn about algorithms and design, they learn about both rules-based and data-driven approaches to algorithms. They learn the mechanics of machine learning as well as deliberate societal impacts such as bias. In the computing and society concept, students learn about history of computing, the development of emerging technologies like AI and quantum, the relationship between humans and AI, and how people decide whether, when, and how to use these technologies responsibly. After students develop a strong foundation, they may elect to pursue advanced domain-specific learning aligned to high school specialty standards. This is a new feature of the 2026 standards. These high school specialty standards are organized into seven areas. Those are AI, cybersecurity, data science, game development, physical computing, software development, and X plus CS. And each of these domains has its own set of standards. Um, the standards, another new feature of the 2026 standards is an interactive web display. We've built this to make the use of the standards optimized for teachers, and it integrates all of these resources and clarification information alongside the standards. So what you see here is filtering a much larger set of standards to just those of a particular grade level. And then on the right-hand side, there are these cards. They represent each standard. If I click a card, it will expand with more information that clarifies that. The boundaries, its alignment, how I could implement it in the classroom, interdisciplinary connections, how this progresses over time, like what comes before and after, as well as some resources to implement that. I can click a lot of things and expand it. I can also customize the view for how this works. Another feature of this is there's an integrated glossary. Um, and so I can see those terms defined directly within the standards. And I can also view the 1,000 plus terms defined in its own interactive display. This work was only possible through a really broad community effort to define CS education for the next generation of pre-K 12 students. The team involved 25 writers, 70 advisors, and 450 reviewers who all contributed a lot. We had a number of research partners, funders, organizations, curriculum experts, state leaders, and educators across the field who each contributed a lot to this. And this would not be possible without all of them, including your support. And we thank you so much for making this possible. Um, my hope is that these standards help establish a new baseline for what it means to be educating computer science. Not simply to be able to use computational tools, but be able to understand them, to create with them, to question them, shape what comes next. And I think there's an important opportunity for CSTA and ACM to continue connecting that vision from the earliest years all the way through post-secondary computing education. And I'm excited to think about how we better bridge that gap in what's to come. I invite you to view these standards as well as a number of accompanying resources at csteachers.org/PK12 standards. Thank you.